So, I'm very good evening to one and all. So, very good evening to one and all. Thank you for joining. Is my voice is clear? Can anyone respond in chat box? Is my voice is clear? Can anyone respond in my chat box? Yeah, Suja, today waiting for the topic. Yeah, I'll come. So, is my voice is clear? Can anyone respond in chat box? So then only I can move further. So very good evening, Reddy, Naradamurthy, very good evening. And then Annamali, very good evening. Priya, good evening. Radha Krishna, very good evening. Yeah, it's clear. Sorry, sorry late. So no issues. Naveen, very good evening. Thank you for your presence. And then Tube, yes, thank you for your response. Very good evening. Today we are gonna see the introduction about Verilog. It's a HDL hardware description language. So and then we'll see some Verilog code, design code for combinational circuits like a full adder, mux, demux kind of thing. So and then at the end of the session I will tell you why. So this masterclass, this 30-day masterclass are fully based around SystemVerilog. But you must know what is a Verilog. Then only you can move further into SystemVerilog. So we'll see today in basic intro and then working of Verilog, how to write this Verilog code. Okay, I think you forgot to share our previous class notes, sir. Mohammed Tawfiq. So we can't share the notes in YouTube directly. Whether you can purchase our internship program, via that we can share the notes. So very good evening, Jax. Very good evening, Mohammed Tawfiq. Thank you for joining. So and before going to start, I want to ask one thing. So how many people are familiar to Verilog? Verilog syntaxes. Are how many people are ever tried Verilog code to make some circuits for like full adder, half adder? How many people are know the Verilog coding language, HDL? So just if you guys know the Verilog means, just put S in chat box. Then only I can identify that you guys are knowing the Verilog language. Okay. So how many people are knowing the Verilog language? Verilog or VHDL or any coding language. How many people are familiar with coding languages like a C++, Python, and then not the HTML, C, JavaScript, JSS, not like that. I'm fully focused on coding languages like a Python, C++, C, embedded C, Verilog. How many people are familiar with coding languages like controls, like control statements, if else, for loop kind of things? Yes, Priya, yes, Nandini, yes, and then Jagadish, you don't know. So good evening. So Wilson Paul, very good evening. But you teach the Verilog from the scratch, sir. So in this masterclass I can't take from the scratch of Verilog. Why? Because of this masterclass fully based on the verification, SystemVerilog for verification only. But as a VLSI engineers, you must know Verilog concept and also SystemVerilog concept. By using the SystemVerilog language also, we can write the design code. But in this 30-day masterclass, we will start from the scratch of SystemVerilog language. Okay. Yes, bro. Radhakrishnan, thank you for response. So and then gamer not familiar. So don't worry. So SystemVerilog also based on the C concept also. Verilog, SystemVerilog, there is no that much difference. There is a similar, but there is only one difference between the Verilog and data type. Verilog and SystemVerilog is data type only. Okay, data type and OOPS concept. So Verilog don't have OOPS concept, but in SystemVerilog it having OOPS concept and then assertion coverage things we will see in this 30-day masterclass. The basic thing is Verilog is very simple language for design the hardware. To design the hardware in the coding by using coding means we can use Verilog and then VHDL. And also nowadays we can write the design code by using the SystemVerilog also. Okay, so we will see the very from scratch to advance in this 30-day masterclass of SystemVerilog. Okay, I'm doing research work in VLSI, ULSI. Thank you for good. Annamalai, it's very good for you. So I think most of people are aware of Verilog. Okay, don't it's very good for us. So in this session we will see the main thing is there is no that much difficult to learn Verilog. So there is a simple syntax, and then main thing is, so firstly I will tell you what is HDL. So HDL is nothing but hardware description language. So by using this HDL language we can describe the hardware. It means, so for example, if you taken like a IT sector, they are writing some Python code, JavaScript code or C code to describe the software, how the software will work, how the software have to do some things. For example, AI means we are mostly with dealing with Python with the AI. So in the Python code, what we are doing? So we are telling the functionalities as we required. Same like in HDL, auto description language, we are describing the functionalities of hardware. Okay, and then after that we are making we are implemented or we are dumped into main hardware. For example, while making the chip, firstly we have to design the spec. So what for if you want to make one chip means, firstly we have to clear with requirements and then functionalities. Okay, and then we have to write the design code or HDL code for our functionalities. After that I can convert into Verilog code into gates and gate into transistor, and then we can make a transistor in this physical chip. So we can this is a way of making chip making we've seen in the first day of the masterclass. Same like that. So the main thing is we have to aware of HDL. HDL means nothing but we can describe the hardware, how the particular chip will work. So controlling the hardware, it means controlling the transistor based on the HDL language only. The main thing is we are only focusing on hardwares. So if you take an example like hardware, any chip, it having some input and output pins. So what is the input, what is the output? So this is the main thing of our HDL language. We are giving some input and then we are waiting for some required output. If it is comes means it's okay, that particular chip or that particular thing is working correctly. Okay, so we have to make that chip working correctly means we have to write the Verilog code as much simplex and also perfect, so that we need to know some basics knowledge about number system, digital electronics, conventional circuits, sequential circuits, clock functionalities. So and then one more thing is, while dealing with if you are writing some Python code, JavaScript or any C code, if you know the syntax, if you know the functionalities of the C code means you can develop your own code. You can make your new logic by using these high level languages. But in the HDL, Verilog or SystemVerilog, we are dealing with only based on the hardware means transistors, clocks, that only conventional circuits, sequential circuits, gates, transistors, clocks, flip-flop, D-flip-flop. This is a thing we are dealing with. We are dealing in the code. Okay, for that you must have have a knowledge about digital electronics. This is a base. If you didn't know the digital electronics basic means you can't write the Verilog code. So writing Verilog design code is very simple, but you have to have the knowledge about digital electronics, sequential circuits, combination circuits, and so on. And then functionalities of clock, and then setup time, hold time, kind of things. We have to know the theory part, then only we can implement into code. So while writing the design code, you must familiar with the theory part and also coding part. Coding part is very simple. There's a simple syntax only. So I hope this is clear for you. Hello Manigandan sir, Shankar Ganesh. Thank you for response. So and then nice session, Srinu H. So thank you for response. Not your research work. Please don't share research work. So good evening. Please share some notes on the knowledge about basic and coding part. So we will see in this session. Lamba, Manmeet Lamba. We will see in this session. So okay, we will get into session. Introduction about Verilog HDL. So HDL is nothing but hardware description language. By using this language, we can describe the hardware, how you have to work. Okay. So and then before going to that, yesterday we seen some conventional logic, sequential logics. So do you guys ever have deep flip-flop? So yesterday we are focused. Yesterday we are seeing only some deep flip-flop logic only. So how many people are knowing deep flip-flop? So if you guys know the deep flip-flop, so what is difference between Vivado and Xilinx? So Vivado and Xilinx are same only. So it is depends on the vendor. So in the market, mostly FPGA boards are given by two vendors. One is Intel, another one is AMD. So AMD having the FPGA company of Xilinx, Intel having the FPGA company of Altera. For the Altera FPGAs, they are providing tool like Intel Cortex Prime. For Xilinx FPGAs, the AMD company are giving the tool like a FPGA tool, simulation tool is a Xilinx and Vivado. So Xilinx and Vivado same. So based on the board family, FPGA board family, FPGA board variant, they will differ. Up to the Spartan 6, you have to use the Xilinx, okay? But advanced version of FPGA from the Xilinx board like a Xilinx FPGA, Pink FPGA, Xilinx 7000 series, Zinc 7000 series. For that advanced board, you have to use Vivado FPGA tool. Vivado is one tool, FPGA tool you have to use for advanced FPGA boards. For old boards, you can use Xilinx. So toggle flip-flop. So how many people are knowing this T flip-flop, toggle flip-flop, how it is work? So what will happen if the T is a one input of toggle flip-flop, if it is T is equal to 0 and then T equal to 1. If the T equal to 0 means what will happen? If the T equal to 1 means what will happen? If can anyone respond in chat box what will happen if T equal to 0? So can anyone respond? So Narayanamurthy, you can respond. If you know means you can respond in chat box. So if the T equals 0 means what will happen? So what is the output? If T equal to 0, if it is T equal to 1, so what is the output? So if you guys know the T flip-flop functionality means you can answer in chat box. So if T flip-flop is nothing but toggle flip-flop, when it will toggle, when it will won't toggle. Okay, if the T equal to 1 means it will toggle. So I think Naga Srinivasar. So you are telling correctly 0 no change. If the T equal to 0 means no change, and then if T equal to 1 means it will do toggling. So it will do toggle means whatever you given output input, it will give the opposite. It will do toggling 0 1 0 1. Okay. Thank you for your response, Roy Chaudhary. T equals 0 means retain previous state. T equal to okay. T equal to 1 means toggle. So Roy Chaudhary, you are telling exact answer. So thank you for your response. I hope I'm very happy some people are knowing with sequential logics. So this is a basics. So if you are very good in basics means you can write the design code. Why? Because of Verilog code is fully depends on this only: sequential logic, combination logic, flip-flops, clocks, and that only. So okay, let's get into session. Okay, thank you for response, Narayanamurthy, MPSS, Nagajodi. So thank you for response. So and then before going to see the syntax of HDL, I will tell something about case sensitive and then how to command the lines in Verilog code. So this so Verilog is a case sensitive language. All keywords are in lower case. It's like a white space. It having some white space commands, operator, number specification, string, identifiers, and keywords. So we'll see one by one. So how it is to look like white space, how it is look like commands in Verilog code. Okay. So before going to that, how to command. So command means just if you are writing the code, the one line, if you don't want to means you can command that line. So by using this double slash, you can like command the single line. By using this procedure like a slash star and then end of the paragraph like a star slash, you can command bulk of lines like n number of lines by using this method. Okay, so these are very basic things. Okay, commanding of lines, this is very basic. And then operators, and then we have the three operators. One is unary operator, binary operator, and the ternary operator. Okay, so you can see here, if a equal to, I'm assigning to a, I say minus of b, it's a negative of b. It is an unary operator. And then if you are dealing with the logical AND operation, so logical, this is a logical AND operation. So before going to that, I will tell you this this symbol is refers to AND gate. Okay, if you are using the double ampersand symbol, means it is refers to logical AND. Okay, there are a lot of operators in the Verilog, so I will show you one by one. So if you are using this, means this is known as binary operator. And then this is a ternary operator. It having some different operations, so it having some different functionalities. How means, if I am assigning to A, if my B is high, if the B value, if my B value is high, means it will choose the C. If it is B is equal to 0, means it will choose D. So it's like a if else condition. So it will check the B. So if it will check the B, if the B having the high, I means 1, so it will select this C. So whatever it having the C value, it may be 0 or 1, that 0 will assign to the A. If it is 0, means it will select this this D. So whatever it having the value of D, it will directly assign to the A. So it's like a if else condition, but we can declare in the ternary operator. So this is a ternary operator working. So while writing the Verilog code is easily understand for you. Ternary operator, binary operator, and then unary operator. So unary operator is a normal operator. I'm just assigning to LHS to RHS. Okay. So and then sized unsized. So and then you can see here while making some signal, like I'm for example, I am using one signal A. This is one input signal for my circuit. Okay, A. If I using this method, 4, this symbol is refers to tick. 4 tick binary of 1 1 1 means, so that particular signal I am storing I'm assigning the 4 bit of inputs. It may be 0 or 1, but I can assign the 4 bit of value to my particular signal. Okay. So okay, good morning, good evening, Bharat Singh. So Radhika, good evening. So and then this is refers to size. This 4 is refers to size of the binary. So size of the signal. This 4 is, if it is 4 means there is a 4 bit. If it is 12 means it's a 12 bit. So you can see here B is refers to binary, and then H is refers to hexadecimal, D is refers to decimal, H is refers to hexadecimal. So here this is a 12 bit of hexadecimal, this is a 16 bit of decimal value, and then this is a 12 bit of hexadecimal value. Okay. So this is how sized and unsized. Sized and unsized. Sized means there is no size. So this is how unsized. This is how unsized is looking. So it's like a syntax. So you can see here I didn't give any value before the tick. It means I didn't give any size. It's known as unsized. Okay. So I will show you while assigning the code. So for example, I will while writing the Verilog code, I will show you what is sized and unsized. So okay, and then identifiers and keywords. So output is like while writing the Verilog code, we are mostly written with the input and output signals. So output is keyword, and then R, NOT, gate is identifiers. Okay. So this also I will show you in the writing the Verilog code. So I am trying to make this session more practical with writing the Verilog code. Then only you can easily understand. So theory part is very boring. So I will fastly move into coding part. So and then this is the main thing. So in the Verilog we are having the two data types. One is net data types, another one is register data types. So register. So these are the two data types. Net data types and then register data types. So net data types, it's used for getting the values from the circuit. Okay. So register data types are mostly used for to give the input for circuit. Okay. So each and every data types, net and register data types having some value. So it means states. It means, for example, this is a data types net and register. Net means we can write the wire keyword. Wire is one data type of it comes under the net data type. So by using the wire only we can get the output from the circuit or any logic. So and then register. So register is nothing but it can store is like a name itself. It having register, it can store of datas. So the register, it means reg. While writing the Verilog code, you can see that reg. I am using one reg keyword. I will use one reg keyword. It refers to register data type. So each and every data type it having some states. States is nothing but it at that particular signal, I am declaring as a one signal as a reg and then as a wire. So it means I am using two data types of for particular signals. So each and every data type having some states. States is nothing but for example, in reg a is means this I'm declaring one variable or a signal reg a. A is a variable name, signal name, and then reg is a data type. So I'm using the register data type to make one signal m is a. So that particular signal, it may be 0, it may be 1, it may be x, it may be z. So it can that particular signal it can be in the form of 0, it can be in the form of 1, x, z. So 0 means we can know that we can say that 0 voltage. 1 means high, 5 volt or 3.0 volt high. 0 low, 1 means high. So it can like a logical 0, logical 1, false condition, true condition for 0 and 1. But here this axis refers to unknown values. Okay, so axis refers to unknown values. Z is refers to high impedance and then floating state. So what is the difference between the X and Z means? So yesterday I said no, metastability state or setup time, hold time. So on that time I already said no. If the particular signals are not stable in the setup time, hold time means that particular signal will move into metastability state. So metastability state is nothing but it is in the x value. So it means unknown values. It will give the unknown values. So that for particular reason we are using a x values. X means unknown values. It means it may be 0 or it may be 1. But here in the z means high impedance. It's a floating state. So that particular signal won't give the stable output. So won't give the 0 or 1. It will give the floating point outputs. Okay, with high impedance. This is the states of data types. Okay. So and then these are the net data types. The net data types, it having a lot of data types, like a lot of types in net data type. This is the first type, wire. We are mostly using this only, wire only. And then try. So try is also one data type, and supply 1, supply 2, wire or try or wire and try 1, try 0. These are the net data type signals. But in the Verilog HDL we are not using these kind of things. We are only use wire data type only, or mostly. So where will these things are using means analog mixed signal. So there is another domain. So not another domain, there is one domain in VLSI is a analog mixed signal, AMS. So the AMS, for AMS it having some Verilog language. So Verilog, so on that Verilog language they are using these later data types. Why? Because of so analog mixed signals are dealing with analog signals. So it may be there is analog signal means it is a floating point signals. It will continuously changing. So 0 1 1 0. So try, and so these remaining types of data types are used in the AMS domain. But we are mostly use wire data type while writing the Verilog code. So and then this is the remaining data type. So integer, real, reg, time, real time. So integer means we know that integer is one data type. It is a 32-bit of signed value. Signed means we can assign the negative value and also positive value for the integer. Why? Because of it is signed. Okay, signed in nature. So and then real. So real means double precision floating point. We can it is a 64-bit width. So we can give the floating point values. And then reg is the unsigned storage of varying bit width. So varying bit width means by using this registered data type, reg data type, I can make the signal, and also I can increase and decrease the width of the signal. Width means I can increase the bit width of signal. And then time means unsigned 64-bit integer. We can see the simulation time using this integer. And then real time is also one data type of Verilog. So these are the basic data types. The main data type is only two, reg and wire. If you reg and wire only we are mostly using, and also integer. So and then arrays. So coming to the arrays, before going to that I want to ask one question. So how many people are aware of the arrays? Arrays, it is very important thing, important of all the languages, arrays in C, arrays in Python, arrays in Verilog, SystemVerilog. It's very important. So array means by using the array we are just in the HDL we are creating the memories. So while by using the array only we are creating memories. So we can create the memory locations, we can set the memory locations, like means 10 memory location, 20 memory location. By using the array only we can make the memory in HDL. So arrays are allowed in Verilog for reg data type, integer data type, time data type, and then vector register data type. And also arrays not allowed for real variables, real type signals. Okay, a multi-dimensional array are not permitted in Verilog. That's why we are using currently SystemVerilog. Multi-dimensional array are not permitted in Verilog. Okay, multi-dimension is nothing but it having a number of rows and columns. This is how arrays look like. So a number of rows and columns are not permitted in Verilog, but in SystemVerilog we having the multi-dimensional array. Okay, so and then it is important not to confuse arrays with net or register data. So vector is a single element that n bit widths. On the other hand, arrays are multiple elements that have 1 bit or n bits of width. What it means, so don't confuse with vectors and registers. So I will tell you how to create the array in the upcoming session, upcoming slides. So the main thing is syntax. So firstly, while creating the array you have to follow the syntax, like a data type and then array name and then starting index, ending index. It means, so we are creating memory only. So while every time while dealing with array, assume in your mind you are creating memory. So in this starting index refers to starting memory location, this ending is refers to end of the memory location. If it means sound down to 0, 0 down to 0 means it will start from 0 and then it will increase up to 7. So totally you will get the 8 memory locations. Okay, starting index is refers to initial first memory location, first of array, and then end index is refers to last memory location of the array. So this variable name is refers to array name and then data type. So we can make the array by using data type, like a register. By using, we can use reg and then we can use wire. Okay, so this is how we can create the arrays. So integer is a data type and then this is array name. So 7 down to 0, it means totally it having the 7 memory locations. Okay, so and then reg bool, this is on array, it having the 32 of boolean register value. So 32 bit of memory location it have. So we can store 32 bit data in this array. And then time is on another array, checkpoint, this is it having some 100 1 to 1 is 1 down to 100 means 1 down to 100 means it having some 100 memory locations. We can store the 100 memory locations by using this array. And then reg, so this is a double this is like a memory creation. So reg 4 down to 0 and then port ID is array name and then 0 down to 7. This 0 to 7, this vector. So you can see here 0 down to 7 or 4 down to 7, 4 down to 0, 0 down to 7. This is known as vector. So you are using single bit means it is not vector, but you are making the signal with the n number of bit, like a 5 bit or 6 bit means you have to create like this only. By using the vector only you can create the you can create the, by using the vector only you can create the n number of bit width of signals. For example, you can see here this particular count. So count is one array. So here it having the vector of 7. So it means it having the 8 memory locations. Same like it having the 7 down to 0. It means 0 down to 7 means it having the 8 memory location. And then, but here you can see here 4 down to 0. It means each and every memory location you can store 5 bit of data. So by default reg is a single bit data type. So integer is a 32 bit, time is a 64-bit, but reg and wire is a single bit data type, so it can store up to 1 bit only. It can perform with only 1 bit only. But here I'm creating one memory. So array having the 8 memory location, each and every memory location it can store 4 bit of data. So I will show you this only. You can see here reg sound down to 0. This is one array. So this is how it will create a memory locations. So totally it created 8 memory locations. Okay, and then so you can see here I'm giving the vector before the array name. It means it will create the memories in the contiguous state. So but here I'm giving the vector after the memory, means it will create the memory it will create the memory like this. It will create the array like this. Okay, so and then memory, I'm telling with I'm always telling memory means while writing the Verilog code, if you want to create the 1 KB of memory, means you can create like this 1 byte of memory. It means totally it having the 1024 memory location. Each and every memory location I can store the 8 bit of data. So this is how memory looks like. For example, if you taken like a ROM, it having some memory locations. Each and every memory location can capable to store n number of data, not n number of bits. It can store 32 bit or 64 bit. Same like that. It having the 1024 memory location. This down to after the name is refers to memory location, and then this vector is refers to in each memory location how many bits I can store. This is referring to how many bits I can store into each memory location. Okay, so this is how array memory creations. So what is difference between real so Pradeep Reddy asked one difference between x and z. So x means unknown values, it may be 0 or 1, but z means it is in high impedance and floating point. So it will giving the output like a, for example, while in your chip you are mostly dealing with input low means 0 voltage, high means 3.3 voltage, but that particular signal are giving output like 0.2, 0.1, 3 3 volt, 3.1 volt, 3.3 volt, 3.5 volt. It will continuously changing with high impedance. It is a floating point output is known as Z. So there is no stable output, means it is known as high impedance floating point output, Z. So explain port. What is difference between real and the real time and then time? So that the main difference is real time. So real time, so it's at time is an unsigned 64-bit integer value. So it means it is unsigned. Unsigned means while if you are creating the data type, if you are created the one in signal using the time data type, means you can assign only the positive value. You can't assign the negative value. Why? Because of it is unsigned in nature. Okay, and then real time is the type of real used for storing the time as a floating point value. It means in the real time you can't store the floating point. So in the time you can't store the floating point value, but in the real time you can store the floating point values. This is a difference, basic difference. Just read these basic definitions and then information about data types. So real time is unsigned 64-bit, so you can assign only the positive values, but real time is same like the real time, but you can assign the floating point values for the real time, like a point. It means 0.1, 1.5 kind of thing. So time equal to highlights that example for this too. Yeah, you were telling correctly, Muhammad Tawfiq. So and then this is how arrays in the Verilog, and then parameters. So parameters on the one concept in Verilog. Parameters values for each module instance can be override individually at compile time. So parameters is nothing but, so if I assume like you are writing n number of lines of code, you are writing the big design code in Verilog. So you are assigning some value for signal. If I assume like a, you are assigning a equal to 5. So you are using a equal 5 at in your code n number of times. A equal 5, a equal 5, you are using n number of times, okay. But you want to change the value of a is 5 into 10. So you have to you have to reassign the value of a into 5, so sorry, 5 to 10. So instead of using 5, you have to use 10. So for that you have to make changes in the all part of your code. So wherever you see the value like a equal 5 means we have to change a equal to 10. So this is very hard task, no. So you are changing the you have to see the every line of the code, and then you have to change the value. A equal 5 means you have to change a equal 10. So it is very hard task. It is very it will time taken also. So for that reason you can use parameter. So if I this is a syntax. Parameter is a like a keyword. Parameter is a keyword, and then port IT is a parameter name. So assume like a this is here, assume like here it is having a. So parameter a equal 5. So okay, if it means wherever you see in the a in your code means the particular a it having the value of 5. So if you want to change the a value means you can change over here itself. If you change in one time, it means it will automatically reflect in wherever using parameter means it will automatically reflect on that places. So if you don't want to change all the places in your code, if you change here means it will automatically override the values. So wherever you use it, that particular signal, this is how parameter use it. And then we can also overwrite means we can also change change means overwrite itself. So Valarmati, very good evening, thank you for joining. Please explain x. So explain x is nothing but unknown values. So for example, I'm getting I'm getting from the IC, from the one chip, I'm getting output like a 0101 only. That particular pin will give the output like a 0 or 1. So okay, so I'm expecting the 0, but it is giving 1. It means at the stage I am expecting 0 output, but it is giving 1, and then it will giving continuously 1 1. But it is not giving my expectation results. It is giving some unknown values. This is a unknown explanation. So it will give the output unknownly. So it may be 0 or 1, we don't know, but it will give the output but unknown. So it won't give the expected output. So how it is giving us expected output means that particular signal, if it is based on a sequential logic, means if any happens, any unstable happens in setup time, hold time, means it will give the unknown values. You are expecting 0, but it will give the 1. You are expecting 1, it will give the 0. This is the unknown values, getting unknown values, x values. Okay, it may be 0 or not. We don't know that it may be 0 or not. While dealing with simulation, we can see the output like a x. X means unknown values. We don't know it may be 0 or not. It means our circuit, our logic is not well. Why when we are getting the x means if our design code is very bad and then it's wrong, and then my logic is wrong, and then there is a timing issues in our code, means we will get the unknown values. Okay, so I think it's clear for you. So overwritten means changing. So and then changing means so already it having some value, so I'm just changing means I'm doing the overwriting the values. Already it having 5, but I am instead of 5 I'm changing into 10. This is a overwrite. So I think it's clear for you, Jay Kumar, what is a x. So Varalakshmi, good evening. So and then before going to that, I will show the syntax. This is a syntax look like. It will start from module name. This is a port list. Port list is nothing but you are every time you are writing the Verilog code, you assume like you are writing some design code for chip. So chip having ports. Port means pins, IO pins. Each and every chip having IO pins, input pin, output pins. So we have to write that pins here. So input and the output pins in the port list, and then you can write here logic. Okay, and then it will complete with 10 module. So this is how Verilog syntax looks like. So and then before going to the next, I will share one important thing about regarding internship program. So if you guys are really interested in this 30-day masterclass on advanced VLSI design and verification, you can convert into 1 month of internship program. Okay, you will get the benefits. These are the benefits you will get the from the internship program. Okay, you will get the all the details recording session. You can, and then you will get the PPTs and then resource files, resource codes, and then you will get the exclusive 4+ projects, and then you will get the IETE confirmation letter. So IETE is a central government institution. It's like a IIT, NIT kind of colleges. So and then you will get the 180 days of LMS course access. It is literally 6 months of access. You can watch, and you can watch our recorded sessions, and then we are providing the weekly live sessions for the internship candidates. We are providing the weekly live sessions, and then on the time you can ask doubts, and then we are giving the weekly task to complete, and then to see the report, and then only we are provide the internship certificate. And then we are providing also academic internship report. So by using this means you can get the report. So it is very useful for while you are studying in college. Your college students means it is very useful for you. So and then you will get the, finally you will get the internship certificate from IETE. So this is a high valued certificate. So these are the benefits you will get at the discounted fee of just 999 of our internship program. So our regular fees we are providing in just 499. This is our regular fee, but in this 30-day masterclass period we are providing just 999. So by using this registration link, you will get the internship program, and also you will get the link in chat box. By clicking on this, you can see this window. So here in this window you have to fill the basic details: name, email, WhatsApp number, department, institution name, and then domain. Here in the domain you have to choose which domain. So you have to choose advanced VLSI design and verification. Then only you will get this program, this VLSI program. Why? Because of we are providing a number of lot of internship program. So you have to choose this correctly, then only you will get that. So this is a form fill of registration link for internship program, and then you will get this certificate at the end of the 1 month internship program from the IETE with Pantech. So this is a sample certificate you will get at the end of the internship program. So this is a procedure to get the internship program, and this is the benefits you will get. All that is recording session, LMS course access, PPTs, downloadable course, and then weekly live sessions, and then you will get the internship certificate from IETE. So these all things you will get at the discounted fee of just 999. By using this link you can register for the internship program. So I think it's clear for you. So and then we'll move into, thank you. Okay, I will move into the coding part. So I shown you, I think I shown you syntax. So syntax is nothing but module, end module name, port list is nothing but our input and output signal, and then logic here. So I'm gonna use EDA playground. So before going to that, I will show you. So for the verification we can use Xilinx, Vivado, Intel Cortex Prime, and then EDA playground, model sim. So we can by simulation. If you want to do simulation means you can use this tool. So here now I am going to use EDA playground. This is an online simulator. Okay, you can write the design code, and you can try the test bench for your design, and then you can see the waveform on this. It's an online simulator. On this tool you can see the waveform and then results. So here it having the 3 domains. You can write here design code, and then you can write here test bench code, and then you can write here you can see here results of your design code, output of design code. Okay, so and then here you can see that like you can see here languages. So and then here also you can see that tools and simulators. Here you can see lot of tools here, lot of simulation tools. From the tools you can use anything. So mostly we are gonna use Simon's Costa Sim. Just a minute. Sorry for that. Okay, it's clear. So here we can write the design code. Here we can write the test bench code, and then here we can see the output. So here in this you can see here it having a language assistance tool. If you click means you can see here VHDL, Specman, Verilog, SystemVerilog, Python. So we can write the Verilog and SystemVerilog code here in this EDA playground. So or else if you want to real tool means you can use Xilinx for while doing the design code. But in this masterclass we are mostly dealing with verification. For that we have to use one tool is a CostaSim. So CostaSim is one tool, is given by Siemens, is a one EDA company. So this is a tool we are going to use in this EDA masterclass. So I will share the procedures to how to install the tool in the upcoming days. Today we will use this EDA playground online simulator. Okay, so firstly I will write some syntax. So firstly I am telling the data types. So reg and I think it's visible for you. Reg and wire is a two data types. Reg is comes under the reg data type. Wire comes under the net data types. Net data types are having the lot of data types like try 0, try 1, and then supply 0, supply 1. Okay, mostly we are using the reg and wire data types. Okay, and then this is the two data types. So how I can get a signal? It means reg a. It means this is a signal name. So reg a is signal name. So it can store up to only 1 bit of data. It can perform with only 1 bit of data. And then this reg is data type name. Okay, and also I can create like a wire a or wire b. This is another signal, and then this is the another signal with the data type of wire. By same thing, same like real, I can use real C, and then real integer t. So this is how we can declare the signals. Okay, so let's get into syntax. It will start from module name. I'm gonna write the design code. I'm gonna write the code for full adder. Okay, I'm gonna write the design code for full adder. So end module. This is the first step you have to do while writing the Verilog code. So I'm going to describe the functionalities of full adder in my Verilog language. Okay, so for full adder, what is the logic for full adder? So for full adder here, so for full adder, so this is a full adder black diagram. The inputs are A, B, C, N. There are 3 inputs, and then sum and carry is my output. 2 output, sum and carry is sum is one input, sum is one output, and then C out is another output. So this is a 3 input 2 outputs of full adder. So we know that what is the equation of sum and carry. So before going to that, I will ask one question. So how many people know the equation of sum and carry of full adder? How many people are knowing the full adder sum, carry and equation? Why? Because of if you know the equation, if you know the functionalities of the full adder only, you can write the design code. So how I can do means, we can see here. This is my mod syntax. This is my here I have to write the port list. Port list is nothing but input and outputs of your logic, your circuit. So I'm gonna write the logic for full adder. Input A, this is my one input of full adder. B is a second input, and then C in carry is my third input. Okay, this is a 3 input we are gonna use in the full adder. Outputs are sum and carry. C out is my carry out. This is a sum. This is the output of my full adder. Okay, Naga Srinivasa, you are telling correctly. So and then Rishita sum equal to A XOR B. So you are telling correctly. So if you know the circuit expression means your equation means you can easily write the Verilog code. Okay, so this is a input output of full adder, and then here in between the module and module I can create the logic. I can write the logic of circuit. So my logic is I want to get the output of sum and carry. So I'm using some one keyword is assign keyword. It is a continuous assignment. By using this assign keyword I can assign the values for these particular signals. So assign sum. Okay, sum equal to a, this symbol is refers to XOR symbol, a XOR b XOR cin. Okay, this is a sum equation, simple. And then carry assign cout carry equation is nothing but a and b or b and c, and then c and a and b, and then c b and c in, and then c in and a. So this is a what carry out equation. You can, if you literally seeing means I am telling the hardware gates functionalities. You can see here a and b, and then b and c in and a. If I'm doing a OR operation for all three AND gate means I will get the C out, carry out, and then XOR a XOR b XOR c in. This is a 3 input of XOR gate, and then 1 output sum. So I'm just writing the hardware functionalities, gate functionalities. Okay, this is the difference between Verilog and some high level languages. Okay, so this is a design code. So this is very simple design code. Okay, here I am written the design code of my logic. So I want to check that. So I want to check whether this design code is working correctly or not. How we can check means I can write the test bench code. Test bench is nothing but another module. From that module I can pass the input to my design code. Okay, so input that if I can pass means I can pass input to my design code means design code will get the input from test bench, and then it will apply into this equation, this logic, then it will get some data, it will get some output, and then that particular output will given to test bench, again given to test bench. Here and in the test bench in the test bench I am writing some display statements, $display $monitor. From that statements I can see the output. I can see the resulted output. Okay, this is how works. For that we have to create another module, that is a test bench module. From the test bench only I can pass the stimulus. Stimulus is nothing but input for my design code. Okay, it's clear for you? I think so it's clear for you. So here another module, this is a test bench, test bench. Here we don't have to give the port list. Okay, this very simple, this only test bench only, but you have to register, you have to create the signals, internal signals. If you create the signals here in this port list means it is a main signals. Inside the port list if you created the signals means it is a main signals. If you created in between the module and module means it is a internal signals. So I am creating the 3 signals A, B, C in. Okay, and then so wire, so output signals you must use wire. Okay, this is a wire. Why pick it off? I am getting the output from the wire only. So register means it can store, but if you want the output means by using the wire only you will get the output. That's why I am using the wire for output signals. Okay, I am registered the signals, internal input signal and the output signals, and then I have to do instantiation. So instantiation is nothing but connecting the 2 modules. So by using the instantiation I can connect the 2 modules. Why we want to connect the 2 modules means Without connecting, I can't give the input for my design code. So I want to pass the input from test bench to design code. So without connect means I can't pass the inputs to my design code. For that reason we have to connect. For the connecting purpose, we have to use instantiation. Okay, instantiations. How we can do the instantiation means, firstly we have to write the module name of your design code, and then we have to give some random name. It's like a instance name of your instantiation, and then we have to open and close bracket, and then I'm going to connect each and every signal. So this is my test bench A signal, this is my design code A signals. I want to connect together. So how we can connect means, dot A, and then open and close bracket. Inside the bracket we have to give A. So this is inside the bracket I am given like a. This is one signal. This signal is refers to, it is belongs to my current module. This A is one another signal, is belongs to my design code. Okay, my design code signal. So I'm just connecting my design code and test bench signals. Okay, so and then I will connect on remaining signals. The dot is very important, and then comma also is very important here, and then B, and then C in, and then sum and carry also. Then only I will receive the output from the design code. C out. So I'm just connected my test bench signal and then design code signals. Okay, after that I want to do simulation. I want to pass the stimulus. So how we can pass the stimulus means, there is one big block, one thread is called initial begin block, initial begin and then end. This is one block, like a module block. It is also one block. This is a simulation time. The simulation will start from here only. Okay, here I can give the stimulus, I can write the display statements. Okay, firstly I'm writing the $display. So $display, it means it's like a printing, it will print the output. So I'm just displaying the sum, and I will display the other things. A in binary. This modulus refers to binary. So if it is modulo B means I will see the output in the binary form. If it is modulo D means in the decimal form. Okay, so and then B in binary, and then C in the binary. So and then sum and carry I will also want to see in binary, and then carry out also I want to see in binary. So after that, double quotes, just put comma over here, and then write A comma B comma C in, and then sum and C out. So this A is refers to this B, this A, this B is refers to this B, this C in is refers to this C in, then this C in, if sum is refers to this sum, then this C out is refers to this C out. Okay, and then semicolon. After that, this is refers to delay 10 nanoseconds. How I can declare that nanosecond means, there's a time scale, take time scale. My simulation time means, if I given like a as1 as2 means I'm giving like a delay, 1 nanosecond delay, 2 nanosecond delay, like that. So after the 10 nanosecond, after starting of my simulation, after the 10 nanosecond I am passing my inputs. How I can pass input means, just I am assigning to A equal to 0. It means I am assigning the 0 for my A signal, and then B 0, and then C in also C in 1. So and then after after some 10 nanosecond I will display my output. So I am using two display statements here. It means it will print two outputs before the stimulus, at the starting stage of stimulus, and then at the after giving the stimulus for after giving the inputs for my design code. I am displaying the outputs. Okay, this is how writing test bench. This is very simple test bench of my full adder design code, design and test bench. So you can see here I am assigning the a equals 0, b equals 0. Okay, this is a single bit of 0, single bit of 1, 0, 0. So I'm given like I'm assigning a equals 0. So but I am instantiated over here. It means I can assign the 0 for this signal also. 0 start from here, and then I assign comes over here, and then it will do performance based on our inputs, and then we will get the sum and carry output, and then I am displaying here test bench. Okay, so and then I will click save here. Is my voice is clear? So I think is my voice is clear now. So after clicking you have to click run, and then you will get the output. You will see the output in the transcript screen. Transcript is nothing but output screen. So you can see here output. So at the starting stage of stimulus, I already said no. Initial begin is the input simulation time. At the initial time of the simulation, A, B, C in, some C out are having X value. X means unknown. Unknown means at the starting stage of simulation, I didn't give any value for my signals. So on the time the simulation will assume like a unknown values. So user didn't give any values for the signal, so it will automatically assign the unknown value. That means X value. Okay. So and then after the 10 nanosecond, I am assigning the value 0 for my A, 0 for my B signal, 1 for my C in signal. So this is my input signal for design code. I am assigning to my design code, and then and then it will go over here, and then it will do some operations, someone carry out, it will execute it here, and then it will get the some output, and then carry out output, and then it will come over here. Here I'm displaying someone see out. Okay, so you can see here my inputs are A equals 0, B equals 0, C equal to 1, C in equal to 1, carry in equal to 1. It means 0, 0, 1. If you add 3 bit means you will get the sum equal to 1, carry equal to 0. So that's why I'm getting here. So you can see here I didn't give any values for sum and carry. I'm getting from design code. Okay, I think it's clear for you. So if I change here, if I change input, if I change here 1, let's see what will happen. So I'm giving the 3 1, A equal to 1, B equal to 1, C equal to 1 for my full adder logic. So what is the output? So if my input of full adder is A equal 1, B equal to 1, C equal to 1, so what is the output? If anyone knows means just put answer in chat box. I think my voice is clear now. So I feel like tired, that's why I'm speaking a little bit slow. So my question is, for the full adder logic, the inputs are A equal to 1, B equal to 1, carry in also 1. So if the both 3 inputs are 1 means what is the output? If you guys know the result means can anyone 1. So sum equal to 1, and then carry also equal to 1. The same thing I will given as input for my design code logic. A equal to 1, B equal to 1, C in carry in also 1. So let's check whether I am getting correctly or not. Sum and carry output. You can see here sum A equal to 1, B equal to 1, C in equal to 1. Carry in also 1, and then sum I'm getting 1, carry out also 1. It means I'm getting correctly of full adder logic. It means my design code of full adder is working correctly, perfectly. My code is very correct. So this is how we can test our code. By passing some stimulus from test bench, we can test the design code. You can see here I'm getting correct result, sum equal to 1, C out equal to 1. This means this is how we can test the design code while writing the test bench. It's clear for you? So how many people are understanding this basic Verilog code of full adder? I'm getting correct output, C equal to 1, sorry, sum equal to 1, C out equal to 1. It means sum equal to 1, carry out also 1. So how many people are understanding this design code and test bench code? It's very simple only. Here I am written the functionalities of full adder. Here I am passing the stimulus for my full adder to test the functionalities, whether it's working correctly or not. Okay. So how we can connect these two module means by using this instantiation we can connect. This is very important. Instantiation. If I miss this instantiation means I will get an error. This is how make the internal signal. This is how we can register the internal signals. This is how we can make the main signals input in. If you are given if you written the input and output signals inside the module means this is the main signal. This if you write in like this means this is the internal signals. Yeah, okay, Nagash, yes, that's correct. So how many people are really understand it? So how many people are good in this writing the Verilog code? How many people are understand it? Can anyone respond in chat box? If you guys are really understand this Verilog code means just put S in chat box. Based on your response only I can move further. So I plan to write another code for today, like a mux code. So I plan to write another code like this 2x1 mux and also 4x1 mux, but due to time, so I can't take more than 1 hour. So how many people are really understanding this code, full adder code? Okay, and thank you for response. Reddy, yes. Naga Srinivasaro, understand it, yes. And then Koluchu, Rishita, thank you for response. Your response, yes. And then Bharatraj Singh, thank you for response, yes. So thank you guys, thank you for listening. This is it today. I think it's clear for you. Yes sir, understand. So Maga, thank you for response. I hope it's clear for you. So this is the basic of coding part of Verilog in VLSI. We are writing the design code logics. We are writing the design code logic, and then we are testing also using test benches. So SystemVerilog are mostly used in design code also, but more than we are using in the test bench part. So why SystemVerilog language are used in test bench part means it having a lot of features. So I will tell you one by one in my upcoming classes. So it's possible we will please show the waveform. So waveform. So for that, in the EDA, in the online simulator, if you want to see the waveform means you have to do some commands, but in Xilinx or any other tool it will automatically you can see the waveform. If you want to see in the EDA playground waveform means you have to create another initial begin. So and then $dump file. Dump.vcd. So don't mind this code. This is only for EDA playground. These 2 lines, and then dump. Okay. And then if you want to see the waveform here means in the EDA playground means you have to click here open EP wave after run. You have to tick here, then only you can see the waveform. but it's showing some error issue here. It won't see the it didn't see any waveform windows here. So I will show you in the Costa Sim. So I will use another tool. Here we can get the waveform, but it would EDA playground uploads. Zero to 50 nanoseconds. I will run my code up to 50 nanoseconds and then run. So I will use another tool, Costa Sim. So I will briefly explain how to use the tool in upcoming days. Just now I'm using Costa Sim tool. So if it's possible, please show the waveform. Thank you. Please share the link for earlier 6 days. You can watch in YouTube also. So I will use. So I'm just fastly written some design code. I will show you some output of full adder code. So I'm going to use one different tool is Costa Sim. So I will show you upcoming days how to use, but I will show the output here now. See the design code, and then this is my test bench code. So Verilog fa.v and then db.v plus acc vsim, my test bench module name, and then you try to use the VS Code. Because of we can see the color of your Verilog code. It is very nice to see. And then run all add wave. Please just show the input and output by the pulse. Yeah, I will show you. Just wait a minute. So in that in the EDA playground, it's not showing. There is an issue. This is a Costa Sim new tool I'm going to use in this masterclass. I will tell you tomorrow how to use this tool, Costa Sim. It's mostly useful for verification. You can see here Costa Sim. This tool is mostly used in industries. While industry people are mostly using this tool only for verification. And then you can also see here outputs. Okay, I can't zoom this particular thing, but you can see the output here. Sum equal to 1, carry out equal to 1. So and then you can see the waveforms of this. I'm giving only one inputs. For example, so I think visible for you. I can't zoom here. So at the initial state, this is my simulation time. It will start from 0 nanosecond. After some nanosecond, after the 10 nanosecond only, it will go high. It will change. This is green lines are good. This red line refers to unknown values, x values. Okay, After up to the 10 nanosecond, it is displaying the x values. After 10 nanoseconds only, I am passing inputs a equal to 1, b equal to 1, cin equal to 1, so that I am getting the sum equal to 1, carry equal to 1. You can see here it will going to high here, high. So it will, you can see here, initially it will low and then it will going to high. Why? This signal refers to a, this refers to b, this refers to cin, this refers to sum, and then this refers to carry out. Okay, these are my output signals. So if I change stimulus, if I change here 0 and then 0, a 0, b 0, and then cin equal to 1. If I change this, again I have to run. So in the transcript, again I have to run .2, and it will do and then it will do again simulation. So and then in the waveform window, you can see here a is low, so you can see here downfall, let's say rising, falling edge, it will going to low. Here also it will going to low, and then cin is high, so that sum equal to 1, carry equal to 0. So you can see here this is a high, it will going to high here, and then C out, it is going to low here. It is staying up to 20 nanoseconds, and then after the 20 nanosecond, I am finishing my stimulation. So this is how waveform window. So in upcoming days we will see the waveform windows clearly, and also I am planning to zoom it. So I can't zoom here, it is not visible for you, I think so. So I will show you clear waveform from the tomorrow sessions. I think it's clear for you. Narayana Murthy, better thoughts. So thank you for your presence. You are still watching my video up to 1.15, so 1 hour 15 minutes. So thank you for your response. So we'll see you tomorrow. Thank you guys. Have a nice day. Good night.